Don't tell anyone. So just a quickie, if you're playing around with resizing your window, let's make a J-frame. So if you click on your frame, you can say add event handler, and under component you can say component resize, and you can call code in here. And you can also I'm clicking on the J-frame itself. Well, I think if you do the content pane, it'll also work. But add an event handler component. You can also pick up if the whole component is moved. And so a good layout manager will do a lot of the work for you when you resize your window. It'll grow and shrink the buttons and so on and so forth. But you can also do things yourself if you like. And notice I got some resizing and moving messages when it first started up, because it starts off, with some size, and then it's given a size when it actually becomes constructed and goes through the initialization code, and it also gets placed somewhere, and so those generate the corresponding events. But if I grab the window, right, it'll call my code every time that it resizes or any time that it moves.
Can you set like a proportion lock where like it would maintain like as you dragged it would always be like a 4:3 ratio?
I don't think J-frames support that directly, but it would be pretty easy to do, because inside your resize event you can say what are the new coordinates, right, and then you could decide what to set them to, and you could adjust them accordingly.
Just set the y coordinate as a factor of the x coordinate.
You got to do a little bit of work there, because it might look really strange if you just sort of pick one and adjust the other, but maybe if you see which one has changed the most from the last time, and then accept that one and then adjust the other one, it would be interesting. So you can always go down to like a very low level, right, and do this stuff by hand, which is where my brain usually goes, just because it's more fun for me to do things than to like figure out things, maybe.
So it wouldn't say when you dragged it would still let you move it around like it's not locked, but then when you let go you could have it snap to your proportions?
That's a good question. Let's try. Let's go in our resize window and I don't know how to set the height. It will probably not do anything until you let go of the mouse, is my guess, because it's going to get repainted at some point, and dragging it around may take precedence. Okay, there should be a set height. Interesting. Oh, maybe set bounds.
Set resizable.
Set resizable. You can turn that off, and then you can't change it at all.
What about set shape?
Or bounds. Set bounds, X, Y, width, height. Let's try it. So
it's
that's
constantly trying to, like,
interesting.
snap it back to where it is.
Yeah. Funny. Yeah.
Oh, it doesn't like that.
That's interesting, because it's maximized, which is different. It's just making it very big.
Hey, that's what the computer screen does.
Yeah, you can like leave that on your friend's laptop.
I once left a counter, an incremental counter, without the new line.
Yeah.
So all you see is all
Oh, cool.
a bunch of
Cool
numbers
patterns.
running around. That was Halloween.
Yeah. When I was an undergrad, I thought it would be amusing to create a file called README, and it contained the sentence cannot open file, permission denied, which was the error message we got on that operating system. So every now and then I would stumble across this file myself called README, and I'd try to open it up and type it, and it would say cannot open file, permission denied. And I'd turn on more and more privileges, and I'd keep trying, and it would keep, and eventually I'd be like, duh. But I would fall for it like every time.
Killed by your own sword.
Yeah, exactly. All right, so punchline here is like you have the ability to go down to a very low level if you like, and take things into your own hands. But a lot of this stuff can be handled for you by a good layout manager. All right, let's talk about the midterm, and then I want to start talking about trees, actually. I said I was going to talk about threading, but I forgot we haven't really talked about trees in Java yet, and we're going to need trees for PA 4. So we'll do trees after this, but let's talk about the midterm for a minute. I did something that upset my poor computer. So I posted a list of topics to think about for the exam. And there's no real surprises in there, but let's go through them anyway. Or not. Let's just do this. All right. So midterm topics. Obviously, classes and objects, right? That's the central thing we're dealing with. So make sure you understand the idea of what is an object, what is a class, right? A class is the blueprint. The object is the thing constructed from the blueprint. I'm gonna pass this around again because some people didn't get it. If you come in late, by the way, and the sign-in sheet has already gone in, come in and sign in at the end, right? It's not like you gotta be here on time to get credit for it. Just make sure you sign in sometime. All right, so classes are the blueprints for creating objects. Objects are the things that you create, the things that you construct. So we have constructors that are used to create an object or an instance of a class. So how do we define a class, right? Keyword class, name of the class, curly bracket, everything else, curly bracket at the end. Public and private. Public and private, right? Mostly we haven't done too much with them, but the main idea is if something is public, then things outside the class can access it. And if something is, if something is private, then you can't have access to it from outside the class. And there's also a protected, which we haven't really dealt with. That's the default, but mainly think about public and private. So if you want to prevent something outside the class from tinkering with a field or accessing a method, make those things private. Okay, and if you want somebody to be able to interface with your class through a particular method or field, make it public. And this gets into the idea of information hiding, where we think of a stack as sort of an abstract data type. So here's what the user can use to interact with our stack. They can say push, they can say pop. They can't say increment the stack pointer. They can't say check stack bracket SP minus minus, right? Those things are forbidden. So SP, stack, those things would be private, but we give them methods to do the things that they want to do, and we make those methods public. And that ties into the idea of setters and getters. So you have a field that you want somebody to be able to read, you make them an accessor for it, so that you don't have to make the field actually public. And if you want them to manipulate it, but only in a certain way, for example, you don't want them to set this field to 0, like the denominator of a fraction, you can make a setter or a mutator. And inside that method, you can say, check to see if they're trying to make this an illegal value. And if they are, do something appropriate. So setters and getters, public and private. And writing constructors for a class. So a constructor basically looks like a method, except there's no return type specified. Okay, any time that you write a method, it's got to specify a return type, possibly void if it's not returning anything. Constructors don't have a return type, so it's something like possibly public, and then the name of the class, parentheses, argument list. Any other method would be public, integer, name of the class, argument list. And you can have multiple constructors based on different types of arguments. So, did I do any short answer? I don't think I did any short answer on this. So, so mostly you're going to be writing code, you're going to be looking at code and answering questions about it, or you're going to be making changes to code. There's 2 questions that are going to be somewhat, I'm not going to say lengthy, but are going to be sort of full-blown things that you're going to write from start to finish. And then there's 4 questions I think that are shorter, that are writing little snippets of code or saying, looking at a piece of code and answering some questions about it and so on and so forth. All right, definitely know about linked lists, right? You did a lot of linked lists for PA2, so know how to set them up with and without a sentinel. Okay. The concept that you have a linked list class and it uses a different class for the nodes, okay, which we've commented you can live without, but we're going to implement linked lists with a separate class for linked list nodes. And just how to do the basic things, right? How to declare an empty list, how to add a new node to a list, how to traverse through a list, following the links from one node to the next, how to search for something, how to delete a node, and so on and so forth. If you wanted a doubly linked list, right, that shouldn't be very shocking. You just have another field in your node class that points backwards, and you do whatever you need to do to adjust that along with everything else. Classes I want you to be familiar with. Definitely be familiar with the scanner class. Okay, we've been using this a lot, mainly for reading from system in, but we also talked about reading from new file parentheses path name as a string. It'll open a file and read from that instead of standard in. And then the main ways that we've been reading from whatever our input stream is either next, which gives us the next word, okay, the next stuff separated by white space, or next line, which takes us up to the new line, next int, which gives us the next integer, next double gives us the next double, and so on. Mainly next and next line are the two we've been using. And next basically takes everything until you get to a white space, a tab, a space, a new line, a carriage return, a vertical form feed, whatever, and next line goes to the end of the line. And then along with each of those, we have a corresponding has next method. So has next line, has next int, which tells us if we make the corresponding call to next line, next int, is it going to succeed? Is it going to come back right away with whatever it is we're requesting? So if has next is false and we call next, it's going to block. It's going to sit there until something becomes available.
I have a question.
Mm-hmm.
So when we delete the node, do we need to replace free?
You don't need to free memory when you do something like delete a node, right? So there's a garbage collector in Java, so we never have to do free ourselves. Once we have something that's essentially a memory leak that has no references to it, the memory will get reclaimed automatically. All right, so scanner is for reading in from mostly standard in, print line and print are for writing to standard out. Make sure you know the string class. So the main things you should know from the string class: string.length tells you the length of the string. There's no null terminators. Okay, strings are not arrays of characters, they're a separate type of object. And they have a length method which tells you how many characters. Hello, length should come back with 5. Character at lets us read the character at a particular position because they're not arrays. We can't say string bracket 2 to read character number 3. So we could say string.character at parentheses 3 gives us character at position 3, which is the 4th character, because it starts from 0. So char at lets us pull out individual characters from a string. 2 uppercase and 2 lowercase return the upper and lowercase versions of a string. So letters get converted accordingly, everything else gets left unchanged. So you don't need to make sure that you only have letters. Substring lets you take a piece of a string and return a new string from that. So substring, you can give it a starting location and ending location. I don't ask you about that, but it's a useful one to know. Compare to you used in PA2, so compare to is like string comp in C. It compares the current string to the argument of compare to, and it returns an integer whose polarity tells you how the two strings compare. And dot equals compares two strings to see if they represent the same collection of characters. And make sure you're clear on the idea of why dot equals is different from equal equal. Right? Equal equal is asking if two objects are the same. Dot equals is asking if the letters in the strings are, or the characters in the strings are identical and they have the same length. All right, make sure you know about the toString method. So toString is just a method, like any other method. We declare toString to be public. We say it's going to return a string. And it can do whatever the heck we want. But the idea of toString is when you take an object and you try to concatenate it to a string using a plus sign, your toString method for that object will be called automatically, and the result of toString will take the place of your object in that concatenation. So typically we use this when we're printing something out. We say print x equals plus name of the object, and it'll call the object's toString method. So typically toString should return a string that represents the value or something pertinent about this object. But it doesn't have to. toString could just exit your program. I mean, it could do anything you want. It could make a window pop up. It could delete all your files, right? But typically it's used to return a string that corresponds to the object. And if you don't write a toString, there's always a toString available because objects have a toString, which prints out the name of the object, and then a funny internal memory location. So when you write a toString, you're overriding the default toString. All right, signatures. So what's the signature of a method or a constructor? I'm doing too much talking.
Isn't it the actual name of the method and then the variables contained in it?
It's the name of the method and then the variables in the argument list, specifically the types of the variables in the argument list, which kind of implies also the number of variables in the argument list. So if you call a method with a particular name and you're passing 3 arguments and it has these 3 particular types, that makes the signature of the method, the name and those 3 types of variables, and it will look in your class for a method with the same name, the same 3 types of arguments. If it finds it, if the signature matches, that's the method that it calls. If it doesn't find it, then you've got an error, and probably you didn't even get to compile. And this applies to constructors also, and so it's not uncommon to have several methods with the same name that take different types of arguments, or several constructors, right, which will all have the same name because they're named after the object, but that take different arguments. So rectangle with no arguments, rectangle with 1 argument, rectangle with 2 arguments was sort of the example we beat to death. Know how to use try-catch blocks. And I had a try-catch quiz that I put up last week, but I didn't actually put it in the main set of modules for Canvas, even though it was on assignments. I don't know if it gives you email when those things appear or not. But anyway, I extended it 1 more day, so I think it's due the 14th now, and put it in the module. So, but know how to use try-catch blocks, right? So try goes around code that might throw an exception. If it succeeds, then it ignores the catch block. If it fails, it jumps to the catch block and ignores the rest of the try block. And if you have a finally block, finally is always executed after either the try or the catch blocks finish. And there's a funny business with returns inside there if you have a finally. Finding the length of an array. I won't fix it on Canvas, but finding the length of an array. So if you have an array, array.size tells you how many elements are in it. Declaring an array and using the new keyword. So for primitive types like integer, that's the declaration of an array. Okay, that says data is an array of integers. And it's analogous in C to saying integer star data. You're not ready to use data yet. If you try to access it, you're going to get a null pointer exception. So that's declaring the array. To actually construct it, you do something like data equals new int and tell it how many integers you want. Now data is ready to go. It's actually got 100 integers in it, and you can use it. But if you have something that's not a primitive type, if you have an actual object like rectangles, Alright, so that's an array of rectangles. We can't use data bracket 0 yet because we haven't allocated space for this, so data equals new rectangle. So now data is an array of 25 rectangles, but those rectangles are still null. So if we want to use data bracket 2, we have to construct a rectangle. And then we can do something like data bracket 2 set height or whatever. And if we try to do this without doing this, right, we'll get a null pointer exception. So arrays of objects, you have to do two constructions. First, you have to construct space for all the references to your rectangles. Then you still have to construct any rectangles that you're actually going to use. So that's the slightly quirky thing about arrays of objects. And then if we want to know the length of the array, again, it's just data dot length. No parentheses. Right, we're not calling a method with strings, you're calling a method which goes through and it counts up how many letters are in your string. With arrays, there's a field in the array called length, which tells us how many elements there are. Alright, so the difference between declaring an array and using the new keyword, finding the length of array, arrays of objects, and how to construct them. Statics versus instances. So static methods and fields versus instance methods and fields. So most of the times when we're talking about something like set height, that we're referencing from an instance of a rectangle, right? That's an instance method. If we say something like data bracket 2 dot color, right, that's an instance field. It's a field that we're accessing as part of this object, right? If we access something as part of the class itself, right, that's a static or a class variable, class field, class method. And we don't need an instance of a rectangle to access these statics, these class methods or class fields. And the example I keep going back to, math.square root. Right, when you want to find the square root of a number, we don't have to construct an object of type math and then use that to get to the square root method. We just say uppercase math.square root. That's using the static method called square root that's part of the class called math. And if you want to define your own static, you just put the keyword static in the declaration, either before the variable type or before the return type of a method. All right, this keyword, so I haven't seen too much of this abuse yet, which is good. This refers to the object itself. And we don't usually need to use it, but if you're writing something in an object and you need to know who you are, you can use the keyword this. Okay, you can also use it to get to fields and methods inside, fields inside the class if you've overridden those fields inside a method. And it starts to tie into class extensions. So extensions, right, class, new class extends old class. Basically makes the new class a copy of the old class. So anything that's defined in the old class, any methods, any fields, you have access to those in your new class. So here's a base class called base, here's a new class called new class, and new class can get to any methods defined inside base. And we don't have to do anything special. If base has a method called blah, we can just say blah. And if we haven't defined a blah inside new class explicitly, it'll search in this subclass base to see if that's got a method of that same name. And if it does, it'll run it from there. But we can define our own method named blah, and if we say blah, it's going to run the one that we just defined. And if we want to get to the blah from the base class, we can say super.blah. Right? So super is like this, except super refers to the class that we extended. And this refers to ourselves. If you don't specify an object or a class when you refer to a method. If you just say blah, it basically means this dot blah. Right, it's the method inside this current class. If I say r.blah, then it's the method inside the object r. If I say math.blah, then it's the method inside the class math, and so on. But if you don't specify anything, it's going to look in your current class. All right, so I'm not going to ask you about Swing, Window Builder, Graphics, or Paint. Okay, the calculator stuff I will not put on this test. I have not put on this test. Which means you'll see those on the final. But we'll get a lot more practice playing with these things and events and stuff before then. So any questions, concerns? Yeah?
We're gonna have to go over the soft copies versus hard copies.
Deep versus shallow?
Yeah.
No. I mean, do you want to talk about it, or were you
No, I was
asking if
just
it's going to be on
wondering.
there? Okay.
Yeah.
No, it's not going to be on there. Yeah.
Okay, so there's going to be 6 questions?
I don't remember.
Okay.
And I'm not going to peek while I'm still recording like I did last time. I think it's 7 questions. 6 or 7. And like I say, there's 2 questions that you'll be writing some code for, you know. I give you kind of a full page for all of these. It doesn't mean you have to fill the entire page. And some of these are going to be very straightforward, okay, if you know what you're doing. And don't feel like you've got to write a novel because what I asked for seems like you can do it in 5 lines of code. It may be doable in 5 lines of code. So don't make extra work for yourself, right? And if you're in doubt, you can always ask. Good? All right. See if my windows sorted themselves out. I still got some weirdness going on. All right, let's talk about trees. So we're going to want to write a tree class. And as usual, we're going to have a separate class for the nodes of the tree. So let me just call this class, let me call it T node. And so what do you think the fields of a T node should be? Let's say this is a tree of integers.
You want your data.
Okay, so let's have integer data.
If it's a binary tree, a left and a right.
Left and a right, right? So, and what type of things are left and right?
T nodes.
They're T nodes. Okay, so you got this. So T nodes are pretty simple. And our tree, so what do we need in our tree? What's the one field that we almost certainly need? What? A root. So root should be a T node, right? So we definitely need a root. And for an empty tree, root's going to be equal to null. So we never do sentinels with trees. Sentinels kind of wreck your recursion, or at least make it really complex. So an empty tree, the root is equal to null. A tree with one node, the root will be equal to that root node. A tree with more than one node, right, this will be the root, and its children, left and right, will be other nodes, and so on and so forth. And then we got our happy trees. So we definitely need a root. So our main method might do something like this. Tree T equals new tree. All right, well, what are things we do with trees? Traverse them. Create them. How do we create them? Yeah, we add things to them. So we might say T dot add. Add some values. And we would hope that this is building something like that. And then we could say T dot traverse, and that would print out maybe a comma separated list. And we could search. So we could say T dot search, give it a value, and it should come back true or false. We might want to delete. And there could be other things that we could do if we were going to go crazy. We could have something to zero out the whole tree, which would be pretty easy because we just set the root back to null. We could have something that clones the tree and gives us back a copy of it, etc., etc. But let's just think about adding and traversing and constructing. Constructing, do we have to do anything? If someone says tree T equals new tree, nothing really has to happen because root is already being set to null. That might be the only thing we do in the constructor. So we don't even need to write a constructor. Let's think about add. And we want to be as recursive as possible because we don't want to work too hard. We don't want to have to actually write code that does anything. So adding an integer to a tree of integers. Remember the basic algorithm?
So if n is greater, you're going to move to the right.
Okay.
And if it's less, you're going to move to the left.
Okay, so if n is bigger than the root, insert it into the right. If n is less than the root, insert it to the left. And we won't worry about if n is equal to the root. That's an edge case we'll ignore. So if n is bigger, then put it on the right. If it's less, put it on the left. How do we stop that recursion from calling itself indefinitely?
Check to see if left or right is equal to null.
Check to see if left or right is equal to null. Right? And if it is, then we just put the new node directly on the left or the right without calling our add function. There's one funny thing about doing this. So if root is null, let's make a new tree node. with a data value of n, and let's set root equal to that. And let's return. So if we're starting off with an empty tree and we try to add our first node, we're just going to create a new tree node, put the data value equal to n, have the root be equal to that. Otherwise, if n is bigger than root dot data, then we want to add to the right. There's a complication here, because root dot right is not a tree, it's a t node. The add method is defined inside our tree class, not inside our t node class. So if I say root dot right dot add n, that's going to give me a compile error unless I have an add method inside my t node class, which is exactly what we're going to do. So we're actually going to have two add methods, and two search methods, and two delete methods, and two traverse methods. We're going to have a set of methods inside our tree class which are really just wrappers which call the t node methods on the root. And so this is a little weird, but it gets better. So if n is bigger than the root node's data, let's take the right node of root, right, and let's call its add method. And then we're done. Otherwise, root left, call the add method. And you're done. So there's the add method for the tree class. Alright, so what about the tree node? Alright, we're inside a node. We're asked to add the value n. So if n is bigger than this current node's data, well, we want to add to the right subtree. We can't just say right.add because right might be null. So before we do that, we have to check to see if we're at the end of our branch. So if right is null, then we know that our new node should go directly on the right subtree, so right should just be the new node. And we're done. Otherwise, if there's a node on the right, we'll call that right node's add method, and we'll return. And then down here, we know that n is less than data. So do the same thing on the left. given that, we don't need all of this. Our add method in the tree class can certainly start off saying if the root is null, set the root to a new tree node and return. Otherwise, all we got to do is call the roots add method. So the tree add is really just a wrapper around the roots, the T nodes add method. But it deals with a particular case where we're starting off with an empty tree. Because we can't just say root.add, right, if root's null. That's an edge case. But if the root exists, then we just defer to the add method in the T node, right, which is the type of object that root is, and it does our usual recursive handling of the insert. So think about this, and we'll code this up tomorrow, and we'll move on and talk about search and traversal, and we'll probably make a two-string method, which will be recursive. So we'll play around with this tomorrow. Wednesday is the midterm, Thursday will be open lab, and Friday we'll start talking about PA4. Wow, moving along. All right, cool. I will see you tomorrow.